Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we normally need to perform the nth term test. We normally need to find the limit of this as n heads towards infinity. But when it comes to this, it is hard to tell by just glancing at it. So we are just going to skip this this stage and just jump to, well, here you've got n factorial. Whenever you have n factorial, you need to think about the ratio test. So when it comes to this, we should use the ratio test. So when it comes to the ratio test, we always need to compute this value here. Well, n is moving from 1 to infinity, so this will always be positive, this will always be positive, the whole thing will always be positive, so we can forget about the absolute sign. So when it comes to the ratio test, we need to compute this value. So that's an plus 1, that's an plus 1. So notice that we don't need the absolute sign here, we don't need the absolute sign. So when it comes to the ratio test, it will be an plus 1, which will be this thing here, divided by an. Divided by an is the same as timesing the reciprocal of an, which is this thing here. So now it's just a matter of tidying this up. So if you tidy this up, visualize this as a block of n factorial times a block of n factorial. Let's just switch these two around. So this one goes over here, and this one moves over to here. Okay, so for this one here, visualize it. Well, remember n plus 1 factorial. n plus 1 factorial will be n plus 1 times n factorial. So this thing here will be this block here. And then when you square something, it means you times it by its exact same self. So that's the exact same self. So visualize this as n factorial times n factorial, and let's just leave this as it is. So now n factorial will cancel out with n factorial here will cancel out with this n factorial, and this thing here you can imagine it as being n plus 1 squared, and then take away this thing here. So it's basically this take away this, which will then give you this. Okay, so well, this whole thing here will then become this, and now tidy this up. This then becomes this, and then this will then become this. So as n heads towards infinity, this thing here will head towards infinity. This thing here will head towards infinity. You've got infinity over infinity. So which is an indeterminate form, so you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate the top, that will then give you this. Differentiate the bottom, that will then give you this. And then now as n heads towards infinity, this thing here is going to head towards infinity. This thing here is going to head towards infinity. You've got infinity over infinity, which is an indeterminate form, which means you can apply L'Hopital's rule again. So differentiate this, that will then give you this. Differentiate this, that will then give you this. So now you can see that the limit heads towards infinity. So the limit heads towards infinity. Why then? Let's go back. Let's go back a few steps. When you get to this stage here, you should just be able to tell that that the limit of this thing will be infinity. Because if looking at this here, you know you're going to use L'Hopital's rule, meaning you differentiate the top, you differentiate the bottom. But when you look at this, every time you differentiate this, it goes around in a cycle. So for example, e to the power of 2x. Differentiate this, you're going to get 2 e2x, and then later on, if you differentiate it again, if you apply L'Hopital's rule again, it will be 4e. You see, this 2x thing will always be around. So you're just going to go round and round and round. And then this thing here, because it's n to the power, even if you have n to the power 7, eventually you're going to come to a constant. Eventually you're going to come to a constant. The point is that when you get to this stage here, you've got e to the power of something here, and then this thing here, if you keep on differentiating this, eventually it will become a constant. Whereas this one here, you're just going to have this e2m plus 1 always floating around. So it's just going to go round and round and round in a cycle. So when you can't, when it gets to this stage here, you should be able to tell that the limit of this will be infinity. So hang on. When it comes to the ratio test, we need to compute this, and then we've just computed the whole thing. It becomes infinity. So going back to the original question, hang on. So going back to the original question, we were trying to determine if this series will converge or if this will diverge. When it comes to the ratio test, we need to compute this. Well, we just computed this, and it equals infinity. So when the value that we just computed is infinity is bigger than 1. So we can conclude that the original series will diverge. So will diverge. Okay.